Hello, let's get started. We are right now starting to talk about carboxylic acids and esters. That's on page 138 of your workbook. Take a look at what our plans are for this session. Originally, our plans were learning how to name simple carboxylic acids and then learn a little bit about reactions. This top outcome is one of the ones we are not doing anymore, so cross that out. What we will do, though, is learn about reactions of carboxylic acids and reactions of esters. To start out, I'd like to remind you what carboxylic acids and esters look like. So if you go to your next page, page 139, I've listed structures of a number of different carboxylic acids and esters that are present in your body, or that might be present in medicine and so forth. Notice to remind yourself what a carboxylic acid looks like. It's a carbon that's making a total of 3 bonds to oxygen. 1, 2, 3 bonds to oxygen. The 4th bond is typically to another carbon, like it is here. Of the 3 bonds that carbon is making to oxygen, 2 of the bonds are a double bond to O. The 3rd bond is a single bond to OH. So carbon double bond O with an OH. That's carboxylic acid. Here is another example. There's the carboxylic acid and the rest of the molecule. Here, you'll notice in this structure down below, I see a carbon here. It's also making 3 bonds to oxygen, carbon double bonded to O, a 3rd bond to O, but that's not OH, it's O carbon. So remember, carbon double bond to O with OH is carboxylic acid. Carbon double bonded to O with O carbon, that's ester. So that's the difference between carboxylic acid has an H, carboxylic ester does not, it has carbon. So here's another ester, here's another ester. So we're going to be looking at both carboxylic acids and esters. This structure here, I see a carboxylic acid, so that's carboxylic acid. This has 3 bonds to O, but it's not OH, it's O carbon. So this molecule has carboxylic acid and it has a carboxylic ester. So make sure that you're able to see the difference between carboxylic ester and carboxylic acid. I will tell you that often the carboxylic part is not used with ester. We'll often just say, oh, there's an ester. Oh, here's an ester. So I'm going to put the carboxylic in parentheses to remind us of that. In the next session, we'll be learning about amines. Amines are here, and I'm going to save that till we get to that. Naming carboxylic acids and esters, remember that that is one of the objectives that we are no longer doing. So I'm crossing that out. You don't need to know how to name carboxylic acids, and you don't need to know how to name carboxylic esters. So what we've done so far is practiced identifying carboxylic acids and then esters. What we'll do next, I'm going to flip the paper over again. What we'll do next is look at reactions. Page 140 is looking at carboxylic acids doing an acid-base reaction. This should make sense to you that if they're acids, they'll react with bases. As a quick reminder, remember that we learned this earlier. Acid plus acid will not react. Base plus base will not react. Instead, what an acid will do is react with a base. Acid plus base typically makes a salt, and then often plus water if it's taking place in aqueous solution. So this is what we'll look at. Carboxylic acids are acids, so they'll react with bases. And you can follow along here. This is your workbook. Carboxylic acids are weak acids. They will react with bases. That's what we were just saying. Acids will react with base to form salts. And I'll show you an example of that. But I think before I show you an example of a reaction with a carboxylic acid and a base, Let me remind you how these reactions look with just a simple acid and a base. So the most common acid we've been working with in the lab is HCl. That's an acid. And remember, what acids do is they donate H+. NaOH is a base. And what bases do is they accept H+. So when that reaction happens, the H+ from the acid and the OH- from the base make water. And then the salt will be the other pair, Na+ and Cl-. So NaCl plus H2O, there's our salt plus water. This is a salt plus water. What I also want to point out with this salt is what you know, the Na+ is the cation, the Cl- is the anion. Of course, when they're in the compound, we don't show those two charges. The Na+ charge cancels with the Cl- charge. We just write NaCl, but you know that Na+ is the cation, Cl- is the anion. This kind of reaction looks just the same when we have carboxylic acids. The only thing that's different is what will the cation and anion look like. So here is a carboxylic acid, benzoic acid. I see a carboxylic acid. Remember what acids do, they donate H+. So when HCl donated its H+, everything left behind was Cl-. When this acid donates its H+, H+ goes away, it gets donated, and everything that gets left behind is what's left over. So the salt that we get, acid, will react with base to make a salt. That's always the case. Acid plus base makes salt. Here the salt looks different, but it's really the same thing as what we had before. It's a salt consisting of a cation. Remember that the cation is the positive charge one, so there's the cation. This is a negative. You can barely see it. I'm going to make it bigger. There's a negative. There's the positive. Positive is the cation, so the negative is the anion. It's still a salt. The one big difference that we see with these organic salts is that unlike here where the formula is NaCl, we're not writing a formula, we're drawing a structure. And since we're drawing the structure, we do keep the charges in place. In fact, I often circle them so that we don't not notice them. So we do still write the charges, even though they overall cancel out. In the structure, we write the charges. The formula we did not, but for organic, we always write those charges. That actually makes it a little bit easier if you're trying to identify if something is a salt, organic salt. If you see plus and minus, then you say, yep, that's a salt. Since it's not just a generic salt like we had here, it came from a carboxylic acid, so we're going to call it a carboxylate salt. It's not just any old salt, it came from a carboxylic acid, so we'll call it a carboxylate salt. So to finish up, I'm going to do the two examples that are shown down below. This is a carboxylic acid. You don't need to go beyond that. That's carboxylic acid. That's metal with OH, that's a base. And so what will always happen is the H+ from the acid and the OH- from the base will make water. What will the salt be? Remember, when the acid donates H+, everything left behind is still left over and it has a negative charge. If H+ goes away, the stuff left behind is a minus. So I'll just copy that. Copy everything except the H. The H got donated as H+. So the stuff left behind is negative. There's our anion. And our cation will be what used to be matched up with the hydroxide. So the anion is what's left over after H+ gets donated. The cation is the K+. So this is our carboxylate salt. What you're going to be learning in the lab is that organic salts always, all of them are water soluble because the plus minus. The carboxylic acid that it started from might be water soluble, might not. It depends on polar, nonpolar. but this is ionic, plus minus, so this is water soluble. You'll be seeing that in the lab. The second example, this looks crazy, but we don't worry about that. I see that it's carboxylic acid, and I see that it's reacting with base, and so then you remind yourself that H plus goes away. Acids donate H plus, so H plus goes away. Everything else is left behind with a negative charge. So it's a little bit of tedious to copy, but all we need to do is copy. I'm copying it exactly like it looked. But now instead of OH, I write O negative. The H plus got donated. What's left behind is negative. There's our anion. What will the cation be? It will be the Na plus. There is our carboxylate salt. And the other product, of course, H plus and OH minus make water. So this is the reaction that you want to be comfortable with. Give yourself a little more practice. Acid plus base makes salt. If it's a carboxylic acid, then we call it a carboxylate salt. It'll be the same though as it was with a more simple acid. The acid donates H plus. The base accepts that H plus. So H plus and OH minus make water, and then the cation and anion combine to form the salt. So what we've just done is acid-base reactions of carboxylic acids.